So as you all are aware that presently we are going through a series of advanced data structures and algorithms, and the current topic which we are learning is about list and iterators in C++, in which in our under which during our previous lectures we have gone through the topic of vectors, and our today's topic is in the continuity. We are going to take one more container which is about which is known as list. So we will be continuing with list for some of our upcoming lectures. So when we talk about list, it is very important to cover some kind of background of your standard template library, and this background also goes with our vector thing. So basically, as already discussed, I have told you that the standard template library is actually we can say it as a set of templates, classes and functions, and this is providing the implementation of common data structures such as vectors. We have already seen it is also having arrays, then stacks can be implemented, lists can be implemented, singly linked list as well as doubly linked list, and there are various algorithms to operate upon these data structures which makes a complete package kind of thing, and that we known as standard template library. Apart from the algorithm and common data structures, this STL and C++ categorically, it also provides iterators and functors, which are kind of tools which makes it easier to work with these algorithms and data structure. Coming to the version of C++ when this STL was kind of accepted as the part of. So originally this STL was designed by Alexander Stepanov, and it was later accepted as the part of C++ standards in the version C++ in C++ in 98. Basically, STL is a generalized template library which we can use with almost every data type without repeating the implementation code, because many functions, many algorithms are given in STL are in the form of template. So when we talk about template, we can work with any data type. Coming to the components of STL, the components of standard template library are basically the features which are provided by this STL in C++. Primarily, these can be classified into 4 types. One is the container, another one the algorithm, third one is the iterator, and fourth one is the functor. And we have also seen all these kind of all these components in in a very brief manner. Now going with the containers, basically vectors which we have gone through in our earlier lectures is actually kind of a container. Container, what we can say is these are the data structure which are used to store the objects. As the name indicates, it contain some objects, and not only objects but the data according to the requirement. And each container under STL is implemented as a template class, and template class that also contains the method to perform basic operations on it. So it is not only the data and the objects, but every container is also having the methods to perform basic operations on it, just because these containers are implemented as template class, and class, you are aware, also class will also contain some methods. So there are methods to perform basic operations on it, and every STL container, be it a list, be it a vector, is defined inside its own header file. So that header file we need to kind of we can say include or import in our program in order to use all the facilities, all the implementations related to that particular container. Now coming to the types of containers, these types of containers are basically 4 types. One is the sequence container, another one is the container adapter, third one is the associative container, and fourth one is the unordered associated containers. So, primarily till this point we are dealing into sequence containers. Sequence containers means the containers which store the data in a linear manner. And these sequence containers are also used to implement container adapters. As far as sequence containers are concerned, that means the data will be stored in kind of in linear manner. There are 5 sequence containers in our standard template library of C++. These are arrays, vectors, DQ, lists and forward lists. So, we have array and vectors. All the these two containers are basically we can say we are familiar with, because we have dealt in these two containers kind of in up to a considerable level of detail. Apart from that, we have DQ, then we have list and forward list also. So, we are going to begin with our container, or we can say our sequence container, which is nothing but list. So, list, when we talk about it is actually a sequence container that stores the data in a non-continuous memory. So, the memory here is going to be non-contiguous, and it will provide the sequential access to the stored data. The data which will be provided will be the access which will be provided over this data is going to be sequential, and the memory is non-continuous, in which these data under list is going to be stored. And it basically implements the doubly linked list, and I am sure you all understand what is this doubly linked list. And when I have named 5 these sequence containers, which are array, vector, DQ, list and forward list. So, the difference between array and vector we understand. Coming to the difference between list and forward list, list basically implements the doubly linked list, which is going to be our agenda for some upcoming lectures, while for implementing a singly linked list we use a forward list. So, that is the difference between the list and the forward list. So, list basically implements DLL, which is doubly linked list, and for implementing a singly linked list we need, or we use forward list, which is in terms of keywords it is written as forward underscore list. And as compared to the vector, if we compare our list data structure with the vector, which we have already seen, the traversal is slow, but once a position has been found, whether with the help of maybe iterator or something else, insertion and deletion can be done very quickly, that is in the constant time. So, why this is having a slow traversal? Because of the sole fact that the memory is actually a non-contiguous memory in which the data of the list is stored. So, as compared to vector, traversal will be traversal will be comparatively slow, but once you have got a position kind of thing, then iteration and deletion are going to be constant time operations. Now, as I was talking about which particular file is to be included, or these these container types or these template classes are described as a part of library, and they have their own classes which are written inside the header files. Those header files are to be included. So, as far as list is concerned, this standard list is a class of the list container. So, it is it is written formally, it is written as std then scope resolution operator list. Now, this is very clear that it is a part of STL standard template library of C++, and it is defined inside the list header file. So, the header file which we need to include is going to be list, and we have this as the class of the list. The class of the list container is standard list. Now, the syntax through which we are going to kind of declare our list data structure is std double colon, which is the scope resolution operator list, and the data type, as I have told you, that these are templates, whatever basic data type you want to make a list of, that data type is to be enclosed inside the angle brackets, and then whatever name of the list you want to kind of keep. So, for example, if you write std list within the bracket int and L1, so L1 is going to be a list of integer data type, or it could be std list character L2, then L2 is going to be the data type for data S2 is L2 is going to be a list of character data type. Now, the first program which we are going to kind of look into, I will demonstrate that first program using each and every step. That means even using hash include iostream, which is kind of a very obvious statement that has to be included, or that has to be written as a part of our C++ program. And then in the later lectures, maybe we will kind of we will not take all these redundant statements, and we will focus on whatever is unique between the code snippets. But here, because this is going to be a first program of a list container, and we are demonstrating how to use it, so let us kind of see with all these statements. So, we have hash include iostream, then hash include list. As I have told you, that list is going to be the header file inside which all these things are defined. Then we have using namespace standard. These are the include statements, and within our main function, what are we going to do? We are going to just define a particular list, and using the iterator, we are going to kind of print the elements of that particular list. So, in order to do that, we are going to define a list inside the main function, which says integer main. In order to define the list, we have used list. We are not qualifying it with std scope resolution operator, because of the kind of statement using namespace standard we have already written along with iostream and a list. So, we have list. It is going to be a part of it is going to be a list of integer data type. So, within the angle bracket, data type is defined as integer, then whatever name of the list you want to have, whether it is L1, L2 or any other name, and the elements within the curly braces which are given here as 12, 45, 8 and 6. And now this statement is actually going to we can say define not only define but initialize a list also in the name of GQ list with 4 elements 12, 45, 8 and 6. All these are integer data type, and in order to print all these kind of we can say all these elements of list, we are going to use the iterator. So, for that we have used for auto I colon in GQ list, you need to print every I, and then after this for there will be a return 0 in correspondence with integer main. So, that is kind of we can say that is a program which is defining a list, or we can say declaring a list along with the initialization also, and then it is printing the elements of the list one by one. Now, we have kind of tried to understood that what is actually this list. So, basically your list is actually kind of a container we can say, which is there which is implementing the doubly linked list. Memory allocation is non-continuous, but it is going to provide the sequential access. All these points we have seen about the your container list. Now, for one way we have seen for initialization, that is at the time of declaration, you can give your elements within the curly brackets and you will have your list initialized. Now, before going into basic operations of this list, we will look into all the ways of initializing a list, so that initialization we are done with, and whatever kind of initialization by whatever means is coming to us, we understand that initialization, and then we will we will be kind of moving forward to your more basic operations. So initializing a list, I mean that's a very common thing. That means assigning some initial values to the list elements, and the easiest way to do is by passing the values which we just did now inside and list to its constructor. So, other ways of doing it are also available, but the way which we have just used, or it can be used in a little bit of tweaked manner. It is given on the screen. So, we have list int L, the assignment operator is here, and then within the curly bracket 1397. Without this assignment operator, we can also work as we just did in our previous program, which was the first one. That list integer L, and within the bracket, within the curly bracket along with L, without initialization operator, we can have 1397. Now, this was actually one way, or we can say the most simplest way of assigning the values to the list elements. Now, let us try to assign the values to the list one by one. So, a list can also be initialized by inserting the elements one at a time, and the function which is going to help us for this is nothing but push underscore back. This is a method which we are going to initialize the list after declaration. How are we going to do that? Let us see that with the help of a code snippet. I am saying this as a code snippet which is given on the screen, just because now every time showing this code, showing all these code snippets of these types, I am not going to write all those kind of redundant statement, that is hash include list, hash include iostream, just for the kind of paucity of time. I am just focusing on whatever is new, whatever is unique in the code snippet. So, here we have list integer L. So, one list of integer data type has been declared, and now we will insert the elements one by one. That means in kind of in number of steps we are going to initialize this list data type. So, we have L dot push underscore back 1, then L dot push underscore back 3, or we can say L dot push underscore back whatever kind of element you want to push back. So, push underscore back is kind of pushing the elements at the last of the list. So, initially a list is empty, so 1 is being pushed back, then after 1 3 is being pushed back, then after 3 you have 9 followed by 7. So, the sequence of the elements will be 1, 3, 9 and 7, and if we want to kind of print all these elements, we can print simply by using the iterator for auto I within the list cout I. So, that is one idea. So, push underscore back is something which is kind of inserting the values at the end. Then we have using then the next idea of initialization of list is we can use a specified default value, that is while declaration of the list or while declaring the list, we will be passing two parameters to the constructor. One is the n, which is going to be the size of the list, and another one is the value, which is going to be the value of all the elements of those lists. So, basically here when we are using the specified default value, a list with a specific number of elements can be initialized by by a user defined default value. So, for this we will be using an overloaded constructor of this list class, which will accept two parameters, one is n, another one is val. So, the complete syntax is given here. So, list integer L, L is going to be the name of the new list, n comma val. So, n is basically, which is what we can say is the size of the list. So, L is going to be a list of size 4, and value of all those 4 elements will be kind of 5. So, if you are going to print all these values or print the values of this L, we can say list, you will get 5, the element 5 for 4 times. Coming to the next way of using initializing list is, this can be done in kind of 2 forms by using another list. So, a list can also be initialized from another list by copying all the elements. Now, in order to copy all the elements of list 1 into list 2, or maybe one list into another list, we can either use a copy constructor or we can use assignment operator. So, both the syntax are given here, which says list, then T is actually the kind of data type, then we have L2 within bracket L1. So, this indicates that L1 is a list which is already kind of defined, it is having its elements assigned, and here we are going to kind of declare a new list which is L2, and all the elements of the list L1 will be copied into L2. So, basically L2 will be kind of a copy of the list L1, because we have used the copy constructor, and within that copy constructor we are passing L1 as the parameter. Another way is, we can say L1 is already ready with us, and then we will say list whatever data type is L2, and then L2 is equals to L1. So, here we are using the assignment operator in order to copy all the elements of L1 into L2. So, we can either use these curly braces with the simple constructor, or we can use pushback method to do it one by one, or we can use a specified default value, or we can go with any other list. That is also perfectly possible. Now, it is not only the list, but we can use any other STL container, compatible container obviously, like array, and within the constructor, in order to initialize the list, we will write down the index of starting and ending. So, here it is, here is the syntax. So, first of all we are going to say list int L first comma last. So, this first and last are nothing but the iterators to the first element and the element just after the last element of the range, and the range constructor of this list allows the users to initialize it from any other constructor, from maybe from a vector, maybe from a set, or even an old array. So, kind of let us try to see this code snippet. So, here we have within this main we have one vector v, and from v dot begin to v dot end, by passing these two iterators within the range, we will be creating one list from this vector. So, we have vector int v is equals to 1 3 9 7, and now with this vector we are going to initialize a list. So, in order to do that, we have written list int L v dot begin comma v dot end. So, this is basically the range, that is starting from begin to one element just after the end, that is the range, and these elements in the range are to be copied into list. So, if you are going to put up a for loop or any other loop in order to examine the values of L, all those values which are there in your vector v will definitely be you are going to see all those values. So, in this lecture, if we summarize, we have looked into this STL in detail and its component. Now, picking one component of STL, which is the container, we drill down into the sequence container, and within this sequence containers we have started with list. Apart from understanding the list, we have also seen multiple ways of initialization of list, and now we will be moving on to more basic operations on the list in our upcoming lectures. Here is a list of references which is being used for preparation of lecture. I hope you have enjoyed the one. I will see you in the next. Till then, take care. Good.